Hi students, this is for all the students that were absent on the day we did our bowling lab. Okay, this is to teach you about Newton's second law and help you out with that. So we had a lot of fun with the bowling lab and we are on page 12, 13, and 14. Okay, so what you're going to do is right here, you're going to write Newton's first law. An object in motion stays in motion unless acted on by an outside force. And right here, you're going to write F equals ma. Okay, well, Newton's second law is best expressed as a math equation. Force equals mass times acceleration. Okay, then in class, I gave students a choice of 3 different independent variables. Okay, but you're not going to get a choice, so just write absent on this right here, because you're not going to get a choice of those because I'm only going to do one lab. Okay, so what I'm going to do is I'm going to take this golf ball and I'm going to bowl into the pins that I have set up right here, okay? And that's going to be my normal group. So my control right here is going to be write down bowling with more massive ball, okay? More massive ball. And my experimental group, I'm gonna bowl with this ping pong ball. So right here where it says experimental group, you can put bowl with less massive ball. Okay, and what are some things that are going to be my constants between the two groups, between the the experimental side and the golf ball side? Well, the controls I'm going to do is I'm going to use the same pins, I'm going to bowl on the same table, and I'm going to bowl by the same person on the same day and with the same force. So write those down. Next, I'm going to write my independent variable, the change between the two groups. The change between the two groups is the type of ball or mass of ball, right? Mass of ball. What am I going to measure? I'm going to measure the number of pins knocked down. Okay, I have 6 pins total. I'm going to count how many pins get knocked down each time. Okay, and now my hypothesis. My hypothesis is if I bowl with a less massive ball, then fewer pins will fall down. My hypothesis is that if I use a more massive ball, I'll get more pins down. If I use a less massive ball, I will get less pins. So if I bowl with a less massive ball, then fewer pins will fall down. Okay, now I'm going to do step-by-step instructions. So I want you to write instructions just in step format. So number 1, get balls. Number 2, get pins. Number 3, set up pins in triangle. Number 4, bowl golf ball at pins, repeat 3 times, record. Next step, bowl ping pong ball at pins, repeat 3 times, and record. Okay, now for let me get a pen here, for my results, okay? For my results, I'm going to make a table. And on the top, I'm going to use the golf ball. And I'm going to do the ping pong ball. And I'm going to make a line here and a line here. I'm going to roll them 3 times. So I'm going to make lines 3 times. And then here I'm going to do the average. To do the average, you add up and divide by 3. And then here I'm going to do number of pins knocked down. Okay, so we're going to make that little table so that we can record our numbers. Okay, so let's do this. I'm going to do the golf ball first. Okay, see if I can roll these into here. Okay, I had 4. Okay, I'm gonna go again. It's 6. Get my ball, pick these up. And I had 3. Okay, now I'm going to bowl 3 times with my ping pong ball. Okay, 3 times with my ping pong ball. Whoops, that wasn't a very good bowl. Okay, I had 1. Sorry, I'm sure you're watching this video. It's a lot of motion, but oops. You guys are better bowlers than me. You can get it right onto the pins better than I can. Okay, I got 1 again. Okay. And the last time, and I got 2. Okay. So now what I'm going to do is I'm going to average these out. Okay. And I'm going to show you how to average. You're going to add these up and divide by 3. So that's 4 plus 6 is 10, plus 3 is 13. And I take 13 and I divide by 3 and I get 4.3. And then I add these up. That's 4 and I divide by 3 and I get 1.3. Okay? So then I'm going to analyze results. Right here in the analyze results, we just write down this in words, is all we do. So we just say the golf ball averaged 4.3 pins, the ping pong ball averaged 1.3 pins. That's all you have to write. Okay, now we turn over to page 14, and we're going to talk about the conclusion. This is the most important part. The first thing we're going to do is we're going to make a claim. In making a claim, we're basically not talking about the experiment anymore. Now we're talking about all bowling, okay? So we're going to make a claim, and we're going to say more pins get knocked down when you use a more massive ball. Or you could say, when bowling, the more massive the ball you use, the more pins will get knocked down. Something like that, okay? So you're talking about all bowling. This is like if you were having an uncle that was going bowling and you want to give him advice, you would say, pick a more massive ball because it will knock down more pins. Now we're going to support that with data. So we're going to say, in my experiment, on average, 3 more pins were knocked down with a more massive ball. On average, 3 pins more were knocked down with a more massive ball. Then we're going to say why. Now this is the most important part of the whole thing. And this is the main part I'm going to grade you on. Okay, is the why. Provide the reason. The reason why this works is because of F equals MA. Okay, when you increase the mass of the ball and make the ball more massive, even if you roll with the same force, you're actually making the force bigger. Because when you increase the mass of the ball, the force that the ball hits the pins with is actually bigger. So let me show you this with math. Let's say your mass of your ball was 1 and the acceleration of the ball was 1. Then we get a 2 Newton force. But let's say now we increase the mass of the ball to 4 using the golf ball, and we still have the same acceleration. Now that we've increased the mass of the ball with the same acceleration, now we have a force of 4. So, 1 times 1 is 1. Sorry about that. I was adding. Okay, so the first time we use the ping pong ball, we get a force of 1. The second time we use the golf ball, we get a force of 4. So just simply by increasing the mass of the ball, we're increasing the force with which the ball hits the pins. So right here on Provide Reasoning, you're going to write down that because of F equals ma, when you increase the mass of the ball, you're increasing the force of the ball on the pins. Write that down. Okay. All right, so let's talk about the questions. Number 1, how was Newton's first law demonstrated in your experiment? Well, hopefully you figured it out, but the pins were at rest. And they did not move until a force acted on them. The pins had their resting inertia, and then when the force of the ball acted on them, they moved. So an object at rest stayed at rest until acted on by a force. Number 2, how was Newton's second law demonstrated in your experiment? It was demonstrated by when we increase the mass, we increase the force. Number 3, why do the bowling pins have to be hit by the ball or another pin to make them move? Well, they have to be hit because that's a force. If the pins are not hit with a force, then they have inertia and they're going to stay in the same motion. They're not going to move. The ball is a force to make the pins move. Number 4, what happens when you change the mass of the ball? Well, what happened was we had more pins knocked over. Number 5, what would have happened if we would have changed the mass of the pins? Let's pretend like instead of changing the mass of the ball, we filled the pins with water and we had more massive pins and we bowled with the same ball. What would have happened? Well, when you increase the mass of the pins, you actually increase their inertia, right? Because mass is a measure of inertia. So it would have been harder to knock down the pins because they had more inertia. Last question. You're in charge of a demolition crew. You're asked to knock down the biggest building you have ever demolished. You're not sure that your wrecker can do it. What can you do to make sure your wrecker will be effective in breaking the building? Explain how you would do this using Newton's second law and the equation F equals m times a, or force equals mass times acceleration. Well, if you look at these wrecking balls, the way that they knock things over is they use a mass. And they accelerate that mass with some force to hit the wall. So if you're not sure if your wrecking ball can hit the building, you could calculate how much force would be given to the building if you use the mass of the ball and the acceleration you're going to hit it with to see if it's enough force to knock the building. Okay, you could also try and use a bigger mass, a more massive ball, so that you could hit the building over. Okay, so hopefully that helps you answer the questions. Write the answers in your own words, and hopefully that helps you guys get done with the bowling lab so that you can do that on your own. Thanks, guys.